Whether you're just getting started on your journey to becoming a data scientist or you've been here for years, you'll probably recognize the KNN algorithm. It stands for K, nearest neighbors, and it's one of the most popular and simplest classification and regression classifiers used in machine learning today. As a classification algorithm, KNN operates on the assumption that similar data points are located near each other and can be grouped in the same category based on their proximity. So let's consider an example. Imagine we have a data set containing information about different types of fruit. So let's visualize our fruit data set here. Now, we have each fruit categorized by two things. We have it categorized by its sweetness. That's our x-axis here. And then on the y-axis, we are classifying it by its crunchiness. Now, we've already labeled some data points. So we've got a few apples here. Apples are very crunchy and somewhat sweet. And then we have a few oranges down here. Oranges are very sweet, not so crunchy. Now, suppose you have a new fruit that you want to classify. Well, we measure its crunchiness and we measure its sweetness, and then we can plot it on the graph. Let's say it comes out maybe here. The KNN algorithm will then look at the K nearest points on the graph to this new fruit. And if most of these nearest points are classified as apples, the algorithm will classify the new fruit as an apple as well. How's that for an apples to apples comparison? Now, before a classification can be made, the distance must be defined, and there are only two requirements for a KNN algorithm to achieve its goal. And the first one is what's called the distance metric. The distance between the query point and the other data points needs to be calculated, forming decision boundaries and partitioning query points into different regions, which are commonly visualized using Voronoi diagrams, which kind of look like a kaleidoscope. And this distance serves as our distance metric and can be calculated using various measures, such as Euclidean distance or Manhattan distance. So that's number one. Number two is we now need to define the value of K. And the K value in the KNN algorithm defines how many neighbors will be checked to determine the classification of a specific query point. So, for example, if K equals 1, the instance will be assigned to the same class as its single nearest neighbor. Choosing the right K value largely depends on the input data. Data with more outliers or noise will likely perform much better with higher values of K. Also, it's recommended to choose an odd number for K to minimize the chances of ties in classification. Now, just like any machine learning algorithm, KNN has its strengths and it has its weaknesses. So let's take a look at some of those. And on the plus side, we have to say that KNN is quite easy to implement. Its simplicity and its accuracy make it one of the first classifiers that a new data scientist will learn. It also has only a few hyperparameters, which is a big advantage as well. KNN only requires a K value and a distance metric, which is a lot less than other machine learning algorithms. Also in the plus category, we can say that it's very adaptable as well, meaning as new training samples are added, the algorithm adjusts to account for any new data, since all training data is stored into memory. That sounds good, but there's also a drawback here, and that is that because of that, it doesn't scale very well. As a dataset grows, the algorithm becomes less efficient due to increased computational complexity, compromising the overall model performance. And this inability to scale, it comes from KNN being what's called a lazy algorithm, meaning it stores all training data and defers the computation to the time of classification. That results in higher memory usage and slower processing compared to other classifiers. Now, KNN also tends to fall victim to something called the curse of dimensionality, which means it doesn't perform well with high dimensional data inputs. So in our sweetness to crunchiness example, this is a 2D space. It's relatively easy to find the nearest neighbors and classify new fruits accurately. However, if we keep adding more features like color and size and weight and so on, the data points become sparse in the high dimensional space. The distances between the points starts to become similar, making it difficult for KNN to find meaningful neighbors. And it can also lead to something called the peaking phenomenon, where after reaching an optimal number of features, adding more features just increases noise and increases classification errors, especially when the sample size is small. Feature selection and dimensionality reduction techniques can help minimize the curse of dimensionality, but if not done carefully, they can make KNN prone to another downside, and that is the downside of overfitting. Lower values of K can overfit the data, whereas higher values of K tend to smooth out the prediction values since it's averaging the values over a greater area or neighborhood. So because of all this, the KNN algorithm is commonly used for simple recommendation systems. So, for example, the algorithm can be applied in the areas of data pre-processing. That's a pretty common use case for KNN. And that's because the KNN algorithm is helpful for datasets with missing values, since it can estimate for those values using a process known as missing data imputation. Now, another use case is in finance. In the KNN algorithm, it's often used in stock market forecasting, currency exchange rates, trading futures, and money laundering analysis. And also, we have to consider the use case for healthcare. It's been used to make predictions on the risk of heart attacks and prostate cancer by calculating the most likely gene expressions. So that's KNN, a simple but imperfect classification and regression classifier. In the right context, its straightforward approach is as delightful as biting into a perfectly classified apple. If you like this video and want to see more like it, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below.